The infinite vasts of the universe hold endless possibilities and secrets. And here's one of the intriguing questions: how life and we as humans would look like on other planets. Imagine a world where the laws of physics, the environment, and the conditions are vastly different from what we're used to. How would we adapt and evolve to survive in these strange new lands? Let's see. Mercury is the closest planet to the Sun and has a thin atmosphere. The temperatures there are extreme, with the day side reaching over 800 degrees Fahrenheit and the night side dropping to negative 290 degrees Fahrenheit. So, what can we do to survive these crazy temperatures and constant solar radiation? Maybe we can magically turn into metal. For example, titanium and platinum can perfectly tolerate high temperatures. But seriously though, there is an option. We could settle underground, where the temperatures aren't so frenzied. If we lived underground, we might evolve with large eyes to better capture light. We might also evolve thicker skin to protect ourselves from the intense radiation. Basically, we have two options: become metal or become moles. Let's move on to Venus. This planet is extremely hostile. First of all, Venus is known for its thick, more toxic than your ex type of atmosphere. The whole planet is covered with carbon dioxide, and its surface is absolutely dry, making it incredibly hot. The average temperature is around 847 degrees Fahrenheit, making it one of the hottest planets in our solar system. Also, don't forget about the crazy pressure. Standing on Venus would be like standing 3,000 feet underwater. Only particular hardy microbes from Earth could survive in such conditions. So, if you want to live on Venus, you might have to become a microbe. But unfortunately, since we're not microbes, we have to wear special gear and equipment to survive there. Maybe we'd have to develop a heat-resistant exoskeleton to protect ourselves, as well as get some new lungs that can filter out the toxic elements in the atmosphere. Let's talk about our favorite red sibling, Mars. The first noticeable change after a few hundred years would be your new skeleton. The gravity on Mars is much weaker than on Earth, so your muscles and bones would shrink. To make up for this difference, you'd have to eat more and probably start going to the gym. Also, you'd have to adapt to the low atmospheric pressure and colder temperatures. You need to retain heat, right? That means you'd need a thicker layer of body fat. Sorry folks, but on Mars, we might become fatter. Another reason to start working out. Another big change would occur in your skin. Your skin is like a big barrier that protects you from harmful things such as bacteria, UV light, looking totally creepy, and so on. So what would happen to it? Most likely, you would turn orange, due to the carotenoids. Carotenoids are a type of nutrient that you get from foods such as carrots, potatoes, tomatoes, and so on. They protect very well against ultraviolet radiation on Mars. They only have one downside. By eating a lot of pumpkins from the Martian farmers market, you'll gradually start to turn orange. But maybe it's not so bad. Maybe life on Jupiter would be easier. Yeah, no, it has no solid land. This planet is made up of hydrogen and helium and is referred to as a gas giant. You would simply float there, like in a huge cloud. And even if you managed to land and try to walk, it would be like moving through a super thick fog. So how would we evolve there? Firstly, we might become much larger in size to withstand the immense pressures. Secondly, the temperature fluctuations on Jupiter are enormous. The surface is terrifyingly cold and the temperature rises significantly under the outer layers of the atmosphere. Thirdly, if you lived on Jupiter, there would be no verbal language. This gas giant absorbs radio waves, so even if you were speaking, no one would hear you. There would be no music either, so no parties. And what's the point then? Hey, maybe we could communicate with sign language, but that's not so simple either. Jupiter is full of wild winds and storm clouds, so it's unlikely you would be able to see anything. So even if we evolved there in some way, our lives would still not be easy. Before landing on Saturn, you would probably want to check out its iconic rings, but you wouldn't be able to do that because Saturn's rings consist of a bunch of ice particles flying in space, so it would be extremely hard to land. So let's go straight to Saturn itself. At first, it may seem that Saturn is not bad for us. Some layers of this gas giant have quite pleasant temperatures. If we dive deeper into Saturn, it gets surprisingly warm, up to 26 degrees Fahrenheit in its second layer. This is an average temperature in countries like Sweden and Canada. But unfortunately, this is only one such layer. The rest of the planet is incredibly cold, so in order to survive on Saturn, we'd have to do a lot of work. In addition to the cold, we'd have to deal with the planet's harsh environment, including its intense storms, strong winds, and radiation. To protect ourselves from these conditions, we'd need to evolve tough skin, again, find some insulation, and so on. Next planet is Uranus. Uranus has a very different environment from Earth, with much colder temperatures, a lack of a solid surface, and a much different atmosphere. It's like another Jupiter, but with blue vibes. It's not that bad though. There's even water on Uranus. The only problem is, the planet is full of ammonia, that nasty stuff we use for cleaning, so don't be surprised if you feel the gross smell. Also, it's incredibly cold out there, almost like a never-ending winter. So what would it be like to survive in such a dark and harsh environment? We'd need thicker skin, again, to cope with extreme temperatures. And again, we'd need larger eyes to see better in all this darkness. We might even have to develop a new hearing system, like that of dolphins. Wouldn't that be fun? Let's move on to Neptune. If human beings were to evolve on Neptune, they would need to adapt to its harsh conditions. Neptune, the 8th and farthest planet from our Sun, is another gas giant. The only difference is this planet may have a solid core. If we were to live on Neptune, we'd need to float or swim in its methane-rich atmosphere. We'd also need to develop gills or something like that in order to breathe. Basically, we'd turn into space reptiles or cosmic fishes. The gravity on Neptune is slightly stronger than Earth's, but strong winds make it difficult to stand in one place. To withstand the wind, we'd need to be much heavier. Once again, you need to eat a lot and pump up some muscles. Yeah, technically it's not a planet, but we still love it and can't forget it. A small, distant, and incredibly cold world. Pluto's even smaller than our moon, and because of that, there's almost no gravity there. It will be extremely difficult to stand on it. To avoid accidentally flying into outer space while playing football, we need to create a fake gravity machine. And if we don't want to feel dizzy, we need to evolve a brand new nervous system. But Pluto isn't all that bad. For example, there's liquid water under the surface, and even some icy mountains. Maybe it would be possible to survive there if we had some serious equipment, clothes, supplies, and… nah, too much hassle. Anyway, from the scorching heat of Mercury to the freezing temperatures of Neptune, each planet has a unique set of environmental challenges and opportunities for evolution. While we may never truly know what humans would look like on these other worlds, it's exciting to consider the endless possibilities. Never stop looking at the stars and asking these questions.
Check out that buff dude over there with the orange skin. He's been chilling on Mars for a hot minute, which is why he looks like he used the wrong shade of self-tan. You see, all those carotenoids in carrots, sweet potatoes, bell peppers, tomatoes, and pumpkins are protecting him from those UV rays. The more he eats, the more orange he gets. And as for his sturdiness, it's all about that Martian gravity. The gravity here makes us perceive our weight differently. And if you want to be a boss on Mars, you gotta eat heavily. Like, if a person weighs 150 pounds on Earth, it feels like no more than 55 pounds on Mars. So, overeating can help shorten that gravity-to-weight gap. Mercury is a whole different thing. It's hotter than Georgia asphalt during the day, but colder than Elsa's castle at night. You gotta be made of metal with a high melting point to be able to survive here. But for us regular humans, we'd be toast. Literally. Even though Mercury is the closest planet to the Sun, Venus is still the hottest one. Life on Venus, more like life on the Sun's evil twin. The temperature here typically hovers around 870 degrees Fahrenheit on average. Surviving at the boiling point of water, or in the extreme heat of Venus, is a challenge for most earthly species. Only a select few can endure boiling hot temperatures. Others rush to Starbucks to grab an iced latte with the first beams of the spring sun. So no human being can really evolve enough to survive on Venus. The only creatures that could thrive there are probably tardigrades and those weirdos who put hot sauce on everything. You wonder what tardigrades are? Well, those are minuscule and adorable caterpillar-like creatures that possess remarkable durability. They can endure boiling water, the depths of a sea trench, and the frigid, lightless void of space. Recently, tardigrades were included in a scientific study aboard a spacecraft that unfortunately crashed on the moon. Scientists speculate that the tardigrades may have survived the impact. Hey, would you like to turn into this creature and live on Venus? We're done with terrestrial planets. Let's move on to gas giants. Now look at this dude from Saturn. He's got flippers and not arms. He's got small holes with no external ear flaps instead of regular ears. Most of this gas giant is colder than your ex's heart, as the temperature is about minus 220 F. You can't walk on it, but you can turn into a snowball or an ice crystal if you're feeling frisky. Things are quite similar on Jupiter, so probably turning into a seal and chilling there is not that bad of an idea. At least you can live there rent-free. And don't even get me started on Neptune and Uranus. These guys are ice giants with no solid surface, so those sharp-clawed dudes you see in movies? Yeah, they don't exist. Plus, these two ain't exactly hospitable to life. I'll stick to my sweet potatoes on Mars. Thank you very much.
"1.5 feet with the Earth's gravity. Verification complete. Now the simulation room will recreate Mercury."
It's so hot in here.
Yes, it's like standing next to a volcano. Your jump is 4 feet high. Now switch to Venus.
Wow, this place looks scary.
On the real Venus, everything is toxic.
I feel no difference.
Yes, the gravity here is almost the same as on Earth. Switch to the moon. Gravity on the moon is 10 times lighter than Earth's, 9 feet. The next one is Mars.
Huh? It's pretty comfortable here.
The gravity here is the same as on Mercury. 4 feet. Now, prepare for the struggle.
Huh? What do you...
There is no solid surface on Jupiter. Although Jupiter is a great deal larger in size, its surface gravity is just 2.4 times that of the surface gravity of Earth.
It's hard to even stand here.
Only half a foot. Got it. Switch to Saturn. There is no solid surface here either, but Saturn's gravity is almost the same as Earth's. Now Uranus.
It's so cold.
It's 5 times warmer here than on the real Uranus.
Seriously? My legs are...
1.7 feet. Gravity is slightly weaker than Earth's. That's Neptune for you. Your jumps are 1.3 feet high. Gravity is slightly stronger than Earth's.
Get me out of here!
Turn off the simulation.
Picture this. You've won a membership to a space gym. You get to travel around the solar system and work out. But gravity changes on different space bodies. So let's find out if you can get stronger elsewhere or if you should keep practicing on Earth. Your spaceship is approaching dwarf planet Pluto. It's getting chillier by the second. No wonder! The sun is over 3.7 billion miles away. You must be glad you brought your thermal spacesuit along, right? To leave the spacecraft, Earthlings would need the help of a gravity machine, since gravity on Pluto is a mere 1/15th of that on Earth. Gravity is the force that pulls you toward the ground. The smaller the mass of a space body is, the weaker its gravity. So, on Pluto, you can't do any sports that involve running. If you did, you'd most likely fly away. You can try out elephant lifting, though. After all, you can't do it back on Earth. On Pluto, picking up an elephant weighing 2,000 pounds feels like lifting 120 pounds. The next stop is Neptune. It's over 30 times farther away from the Sun than Earth. The atmosphere there is dark and cold. You might get overwhelmed by the planet's gigantic size. It's called an ice giant for a reason. Maybe today you'll feel like doing some winter sports? To say Neptune exists in perpetual winter is an understatement. The average temperature on this planet is around minus 373 degrees Fahrenheit. But gravity here is only 10% stronger than that on Earth, so you don't feel much difference. This world doesn't have a solid surface, so you won't be able to leave the spacecraft. Is that an ice hockey rink I see? Grab your ice skates and your stick and get ready to outplay your fellow passengers. How about a quick pit stop on Uranus? This is another ice giant, and gravity here is 90% of that on Earth. You can do a few push-ups inside the spacecraft, as you won't be stepping outside. The slushy surface of the planet is made up of water, methane, and ammonia in its liquid form. There's no solid ground to walk on. But if you somehow found a way to go outside, you'd feel lighter than on Earth. If you weighed 100 pounds back home, it would be 90 pounds here. Can we call this a Uranian diet? When approaching Saturn, please mind its rings, which aren't actually rings. They consist of pieces of asteroids and meteors flying around the planet. Saturn's mass is so big that it attracts many other space bodies to its orbit. And right now, you're one of them. Time to get creative with your workout. You've scheduled a skydiving experience here. If you freefall in Saturn's atmosphere, you'll reach the speed of 30 miles per second. Don't forget to open your parachute. On second thought, though, you won't be able to touch the ground anyway. Saturn's surface is pure gas. Quick fun fact, once Saturn got in the way of the 10th planet forming in the solar system. The planet's debris, which partially makes up Saturn's rings now, could have blended into a planet, but it was pulled into Saturn's orbit instead. You're nearing Europa, one of Jupiter's moons. Gravity here is so weak you feel weightless. Let's say there's a rock climbing wall there. How about you give it a try? Usually, this sport requires a lot of physical strength, but here you'll only have to carry 13% of your weight. Your climb to the top will be easy peasy in these conditions. Entering Jupiter's atmosphere will feel like being inside a cloud. See that red spot in the bottom left corner? That's a storm twice the size of Earth that's been raging for hundreds of years. To have some fun here, why don't you do some jumping jacks? I'll count to 100. Ready, set, go. Gravity here is super strong. It's 2.5 times as powerful as gravity on Earth, so you'll probably get exhausted at the count of 30. Too bad. Uh-oh. Passengers aboard the spacecraft, fasten your seatbelts. You might experience some heavy turbulence. To travel from Jupiter to Mars, you'll have to move through an asteroid belt. Just in case you're worried your ship will bump into something, relax, there's a distance of 300,000 miles between asteroids. Let's stop at Ceres, the only dwarf planet in the asteroid belt. Gravity here will make you feel pretty strong. How about practicing some caber tossing? Cabers are heavy logs that can measure up to 20 feet long. The goal is to throw them as far as possible. Here, a 180-pound pole feels as if it weighs 5 pounds, which is, basically, the weight of a melon. Ready for the Ceres caper competition? Woohoo! Finally, Mars. Remember all those handstands you've always wanted to try? Well, here's the place to do them. Mars's gravity is about 2.5 times weaker than that on Earth, which means you'll probably be able to lift your own body weight without any difficulty. Since people keep trying to terraform Mars, opening a gym here doesn't sound like a bad idea, does it? Passengers and crew members, we're now beginning our descent to Phobos. It's one of Mars's moons. Gravity here is incredibly weak. If you've always dreamed of having superhuman strength, this is the place for you. You can work out here by, say, doing some artistic gymnastics. Start off with a cartwheel, then move on to tricks performed in the air. On Phobos, you can start doing triple back handsprings in no time. Ah, look, Earth is about to appear on the horizon. It sure looks majestic from here, but we won't stop there now. Instead, let's visit Earth's sister, Venus. It has almost the same mass as Earth, which means these planets have similar gravities. Now, Earthlings can't survive on Venus's surface because of the large amount of ammonia in its atmosphere. But let's imagine you could practice some outdoor sports there. Do you feel like trying bumper bubble soccer? That's when you dress yourself in a giant bubble ball vest and keep bumping into other players. People play this game on Earth. On Venus, with its slightly weaker gravity, it might be a little bit easier. But still, you have to consider you'll be wearing a 25-pound ball as a vest, kind of like a hamster back on Earth. Not to mention your outfit will restrict your arms and legs. It's a challenge, but it sounds fun to me. Moving on. If you land on the sunny side of Mercury, you'll experience scalding hot temperatures of 800 degrees Fahrenheit. If you're feeling tired after your space workout, a relaxing, steamy sauna will be just the thing. You'll feel like a brand new person by the time you arrive on the next planet. We'll fly as close to the Sun as we can so that you can have a taste of its gravity. The Sun's mass is huge. It's over 333,000 times the mass of Earth. And gravity here is extremely powerful. You'd have trouble lifting something as light as a bottle of water if you managed to step on the surface of the Sun. Too hot, you say? Well, I imagine it's a whole lot cooler if you come back at night. Haha, just kidding. On our way back home, we'll stop by the Moon. I mean, our Earth's natural satellite. Walking on the surface of the Moon will feel like jumping. You'll be able to jump as far as 33 feet, so why not try some parkour? If you play basketball, scoring a point will be very difficult. But then you can jump higher than the hoop and do an epic slam dunk. And how about baseball? If you throw the ball upward, you'll probably never see it again. Finally, we land on Earth. Sorry to disappoint you, but you're not coming back with any superhuman strength. Even when you were lifting an elephant, gravity was helping you out a lot. It was a good trip, though. Don't you think so?
I hope you feel well rested, because I've got a tough task for you. Don't worry, it's fun. You're going to visit different planets of our solar system and try to run on each of them. Let's figure out where you can run the fastest and where you can barely walk. The fastest man on Earth, Usain Bolt, can run with an average speed of about 23 miles per hour, but his top speed is higher, up to 27 miles per hour. Sadly, we can't all be Usain Bolts. The average person runs at a speed of 6 to 8 miles per hour. But maybe there's a planet out there where you can beat the famous Jamaican sprinters' records. But first things first, what will affect your speed when you run on other planets? For one thing, gravity. Depending on how strong it is on the planet you visit, it'll influence your weight. And in most cases, the heavier you are, the more slowly you run. Plus, on all other planets in our solar system except Earth, you'll have to wear a bulky spacesuit. Without it, your chances of survival there are non-existent. And don't forget about extreme weather conditions on most planets. It's either freezing cold or boiling hot, or very, and I mean it, windy. Anyway, your amazing journey is about to begin. Buckle your seatbelt. The first planet on your itinerary is Mercury. As you sneak a peek at this world through the window of your spaceship, you notice that the planet looks eerily similar to the good old Moon. But just a few moments later, you realize it's just an illusion. All over the surface of Mercury, you see craters left by space rocks. This may make your task of running on this planet way harder. This and your bulky spacesuit. Duh. But you wouldn't survive on Mercury without this protection. The temperatures on the planet are extreme, 800 degrees Fahrenheit during the day and negative 290 degrees Fahrenheit at night. But there's one thing that can work in your favor on this unfriendly planet. Let's say you weigh 155 pounds on Earth. Then on Mercury, you'd weigh around 58 pounds, which means that despite your bulky spacesuit, you can move way faster than you do on Earth. And maybe your speed will even reach 13 miles per hour if you try really hard. The next planet on your itinerary is Venus, also called the Morning Star. While coming closer, you see a world very different from the bluish planet you might have seen in books. Before landing, you have to get through a super dense atmosphere made up of carbon dioxide. And while your spacecraft is descending, you're watching thick clouds of sulfuric acid pass by. Venus is often called Earth's twin because these two planets are of similar size and density. No wonder that on Venus, you weigh almost as much as you do on Earth, 140 pounds. So your weight is a bit smaller here, but don't forget about your spacesuit. And still, because of almost the same conditions on the two planets, you'd be able to run a bit faster than on Earth, at around 8.5 miles per hour. Your first impression of Mars is that it's freezing cold. The average temperature here is about negative 80 degrees Fahrenheit. Even from afar, the planet looks reddish. Once you make your first step on the Martian surface, you understand why. The ground's covered with rusty-colored dust. The same fine dust is floating in the air around you, Wherever you look, you see golden, brown, tan, and even greenish hues. They depend on the minerals that make up the soil. The size of the dust layer varies from area to area, but in most places, it's around 7 feet thick. That can make running much more difficult. On Mars, your weight would be much smaller than on Earth, a mere 58 pounds. This will help you achieve an impressive speed of 12 miles per hour. Aren't you a champ? What's that on the horizon? It looks like a tornado. Is it a dust storm? Then it's time to make a run for it. Dust storms sometimes cover the entire planet, and you can even see the largest ones from Earth. And now you're facing a problem. You see, Jupiter, as well as Saturn, is a gas giant. This means that the largest planet in the solar system, and Jupiter is so large it could swallow 1,300 Earths, doesn't have any solid surface. Well, you'll just have to imagine what your running workout would look like if you could run on Jupiter. This planet has an atmosphere that consists of hydrogen and helium gas. During your descent, you admire thick brown, yellow, red, and white clouds. They make the planet look colorful and beautifully striped. On Jupiter, you'd weigh 390 pounds. You'd have to break a sweat to simply walk there, wearing your clumsy spacesuit. If you could step on the planet's surface, that is. If you tried to run there, your best result would probably be a speed of 1 or 2 miles per hour. To make matters worse, it's extremely windy on Jupiter, with the wind speeds ranging from 200 to 400 miles per hour. Do you see those rings? That's Saturn, another gas giant with no solid surface. This planet's made up of mostly hydrogen and helium, and its temperature and density change the deeper you go. If you decided to leave your spacecraft and step on Saturn's surface, you'd just fall into the planet. But from above, it looks as if Saturn does have a surface. The seemingly solid yellowish-brown sphere is surrounded by several layers of clouds. The visible outer layer is made up of ammonia clouds. Under them, there are hydrosulfide clouds, and the innermost layer is made up of clouds of water. Even though Saturn is a gas giant, your weight wouldn't be very different here, around 165 pounds. That's because the planet's gravity is similar to that of Earth. But because of the conditions on the planet, and your bulky spacesuit, you'd run a bit more slowly there, at a speed of about 4 miles per hour. Before leaving, you admire Saturn's most famous feature, awesome gray, beige, and tan rings. These groups of tiny ringlets are made of chunks of rock and ice. You also spot several of the 53 moons of Saturn. Oh, that's Titan, an icy world bigger than our moon and even Mercury. It's the second largest moon in the solar system. The next planet on your way is a blue-green ball of ice and gas. That's ice giant Uranus. It has this beautiful hue because the light from the sun gets reflected off the planet's surface. Uranus isn't solid. Hit the brakes! If your spacecraft doesn't manage to stop in time, it'll fly through the upper atmosphere and sink into the icy liquid center of the planet. I doubt you'll be able to conduct your running experiment here. So let's just imagine what it'd look like. On Uranus, your weight would be around 138 pounds, and against all odds, you could actually reach a good speed here, at least 8 miles per hour. If you didn't get caught in a hurricane, of course. Extreme storms occur on the planet in the summer when Uranus is heated the most. Then, hurricanes can spread for more than 6,000 miles. The furthest planet from the Sun, Neptune, is 4 times the size of Earth, but 17 times as heavy. The blue surface you see when approaching Neptune is actually a layer of swirling gas and permanent clouds. The planet's mantle is made up of water, ammonia, and methane ices. It's the closest thing Neptune has to a surface. And still, there isn't solid ground for you to walk on. So, once again, try to use your imagination. On Neptune, you'd weigh a bit more than you do on Earth, 174 pounds, but your running speed would be just a bit lower than on Earth, around 5 miles per hour. That's the end of your active adventure. Which planet did you like running on the most?
Okay, picture this. In the not-too-distant future, you're heading out on a space vacation. and you need to decide which items are worth bringing along. But instead of checking the weather forecast, you open a gravity simulator. That's because you need to know how each object will behave on different planets. For instance, should you take this metal shovel with you or not? Well, according to your itinerary, it's going to be a long trip. You're planning to visit every planet in the solar system and even a few moons. But due to the difference in gravity on these space bodies, you're not sure how useful some of the objects you're going to bring along will be. Well, let's start with the basics. Tupperware. I don't know about other space travelers, but us Earthlings carry our Tupperware around everywhere we go. And still, if you were to transport it to, let's say Mercury, it would most likely fly away into the atmosphere. These plastic containers you use to keep your food are too light. And since the gravity on Mercury is 2.5 times weaker as gravity on Earth, well, maybe you'll have to fill your plastic containers up before taking them out of your spaceship to have a picnic. If a Tupperware container weighs about 0.5 pound on Earth, it'll weigh just 1/4 of that on Mercury. Now, if we add some bananas, a handful of baby carrots, and 2 watermelons, then it'll be safe to carry it out of your space vehicle. You'll just have some difficulty making it all fit in a standard-sized container. But wait! Before you do that, you should know that the atmospheric temperature on Mercury can reach up to 800 degrees Fahrenheit. This means that any plastic container will instantly melt as soon as it gets in contact with the air. It'll burn up all the food, too. You can probably try taking a titanium container, that will work, or just stick to astronaut food. Now, shall we say Venus? Okay, Venus. If you were to take the same empty container to Venus, it would behave similarly to how it does on Earth. This is because Venus is also known as our planet's twin. These two have much in common. For example, almost the same size and mass. And when the topic is gravity, the formula goes like this. The bigger the mass and the greater the density, the stronger the gravity. Venus's gravity is approximately 10% weaker than Earth's. So, yes, you may leave your spaceship with your container, empty or full, and enjoy a beautiful and scenic lunch on the surface of Venus. Now, you'll have to figure out a way to eat without taking your spacesuit off, though. The atmosphere of Venus is filled with sulfuric acid, which can irritate your nose and throat and cause difficulties in breathing. Or worse. Much worse. Now, you'll have to forget about taking anything too light outside on Phobos. A little hint for you, it's not a Greek island, not even Greek yogurt, although it's a cool name. It's actually one of Mars's moons. Here, even your spacecraft would need a little extra help to keep close to the ground. If it weighed as much as a school bus, any regular-sized person could pick it up with just one hand. This is because on Phobos, the inhabitants of Earth barely feel the weight of gravity. And be very careful when jumping around because one leap and you may fly straight into outer space.
Passengers on board the Voyager spaceship, please keep your arms and legs inside the vehicle at all times.
Well, you're approaching Jupiter, a gas giant. A never-ending storm is raging in its atmosphere. Plus, there's no solid surface there, which means no landing for you on this planet. If you look out the window, it might seem that you are moving through a giant cloud. But for the purpose of your experiment, it'll work just fine. Try throwing into the air that baseball you brought along in case you get bored of all the space travel. And measure the time it'll take the ball to hit the surface. If on Earth, the ball will fall at a speed of 32,174 feet per second. On Jupiter, the same ball will hit the ground at a speed 2.5 times greater than that. That's because Jupiter is more than 10 times as large as Earth and around 300 times as heavy as our blue planet. Now, if you move your spaceship just a little bit to the side, to one of Jupiter's moons, Europa, the situation will be completely different. Throwing a baseball in the air on Europa will mean never seeing it again. Gravity there is almost non-existent, which means that not only a baseball, but even a grown-up person can fly away any second. Now, on the other hand, if you decided to venture out of the spacecraft to explore Europa's gravitational field, why not try to lift the space vehicle itself? On Europa, a regular Earthling can easily lift up to 1,000 pounds, which is the equivalent of a full-size male moose. Or you can lift a pyramid-like formation of 9 regular people. The choice is yours. When approaching Saturn, be careful. While from afar, Saturn's rings look smooth and solid. From up close, you'll notice that they're made of chunks of ice and rocks floating in space. You won't want to have your spacecraft anywhere near those. There's also no solid surface on Saturn, which makes landing impossible. And the atmosphere is full of ammonia. Keep in mind that it's a pretty inhospitable environment for a human. Now, inside the spaceship, you find a collection of sci-fi books, enough to fill an entire bookshelf. Altogether, they must weigh around 400 pounds. Yep, that many books. And like someone with a superpower, you try to lift over 200 pounds of weight at a time. But guess what? You fail, because Saturn's gravity is too similar to that on Earth. Now, in case you got confused with all this gravity talk, when we're measuring gravity, we're speaking about the power of the force by which a planet or other space body pulls objects toward its center. So, if you need some help in organizing that sci-fi collection in alphabetical order, ask the crew to move the spaceship to a neighboring space body with a weaker gravitational pull, like Pluto. These days, it's not considered a planet anymore, just a dwarf planet and one of the furthest from the Sun's space bodies. You'll need an extra warm spacesuit to wear there. Pluto is freezing cold and has a tiny surface. It's smaller than Earth's moon. But it's a great place to test your strength. If on Earth it's kind of impossible for a regular person to lift an elephant, on Pluto you'll be able to pick up a baby elephant weighing around 265 pounds. Or even a medium-sized elephant that can be as heavy as 2,000 pounds. On your way back to Earth, you make a pit stop on Uranus. The coldest planet in our solar system has an average temperature of around minus 350 degrees Fahrenheit. So, if you attempt to get out of the spacecraft, you'll freeze mid-movement. Although gravity on Uranus is pretty similar to that on Earth, there's one thing that's very different: time. A 2-week getaway on Earth turns into a 3-year-long vacation on Uranus. Now, when you get sick of cold planets, you can travel back to warmer ones. Okay, now, Mars is definitely warmer than Uranus, but its average temperature is still about minus 81 degrees. On Earth, we only have such low temperatures at the South Pole during the winter. When you land on Mars, you'll start to feel light and strong at the same time. Mars's gravity is about 2.5 times weaker than that on Earth. So, in other words, you'll probably manage to lift your own body weight without any difficulty. So, all those handstands you've been dreaming of doing, you've found a place to fulfill your dream.
Hello there. Thank you for coming to the Space Job Agency. We have a whole bunch of departments. Intergalactic jobs, keep it in Milky Way, our solar system rocks, or gases, and many smaller ones. Tired of a 9-to-5 routine on our planet? No problem. Let's see if you have any qualifications for newly open positions. So, we've got here... Oh, an asteroid miner on Mars. As you know, asteroids are some sort of leftovers from times when our solar system was forming. Our scientists believe it's debris left of planet collisions and destruction. Tens of thousands of asteroids are circling our Sun, and most of them are between the orbits of Jupiter and Mars. That way, Mars is a perfect location for this job. Those asteroids can hide a lot inside. They're made of magnesium, iron, nickel. We believe some of them consist of oxygen, gold, water, and platinum. We need those for our industries. We have a station with food and everything else you'll need up there. So, you're in a specially designed spacecraft. You start from Mars, land on an asteroid, and start mining. Our machinery is lightweight and solar-powered, which means you need less fuel. Sometimes we send robots to do this, sometimes people. Robots don't need food or other supplies. On the other hand, they're not so precise as humans. You use similar techniques as miners on the Earth. Basically, you'll need to scrape the material off the asteroid. The majority of the ore will probably fly off, so you'll have to use a big canopy to collect it. Since the gravity on asteroids is so much weaker than on Earth, you'll have to learn how to use grapples to anchor yourself to the surface. That way, you can move around with little effort. Once you're done with one asteroid and the material is sent to Earth, you're going to the next one. Are you good at sports? I can see there is an ad for a ski instructor on Mars. Mars has 4 seasons, just like Earth. And winter there lasts around 6 Earth months because the year there is almost twice as long. The snow there is different because it's made of frozen carbon dioxide instead of frozen water. But don't worry, the best scientists made it completely safe. Snowball fights are not so fun. You get a poor pack of frozen carbon dioxide and a bit of water ice. But snowboarding, sledding, and skiing there are so cool. No, literally, the surface is almost frozen. The snow is not as thick as on our planet, but the surface is very slippery, so it's fun. So, you're going to work there for 6 months, but if you plan to make some extra cash, we're transferring you to Europa, one of Jupiter's moons. Europa is very cold. Its surface is mostly composed of solid water ice, a subsurface ocean we didn't get to see yet. But, hey, our team of space divers is going there in 3 months. I'll check if there's a position open if you're interested. They say this ocean might have twice as much water as we have on Earth. Plus, our team of scientists still think this is one of the best spots to build Earth-like cities in our solar system. But until then, you can go as a skiing instructor. The surface is made of ice, so we created our own snow to go skiing. You'll like it there. There are many hills and domes on Europa. Some ridges are 5.5 miles across. So if you want some adrenaline, Europa has little to no atmosphere, so your suit protects you from radiation from the sun. Okay, the next one is a driver in a space taxi on Venus. Tourists love going there, despite that it's very, very hot. It's further away from our sun than Mercury, but it's still hotter. The thing is, the atmosphere there is like a blanket that traps the heat. The planet is scorching, so you can't stay there for too long. The company will provide you with a flying car that looks like a mini spaceship. You'll have to be a pretty good driver because the atmosphere is very dense. And it's also quite windy there. The speed often goes over 220 miles per hour. And it can get tricky with the clouds. You won't be able to see because the wind's moving them all the time, so you have to act fast. Plus, Venus is the planet with the most volcanoes in our solar system. Much of its surface is covered with volcanic deposits, making it hard to land and find a safe spot to land. If you accept this job, here's a tip. It's better to stay in the air. The view is amazing. Speaking of volcanoes, you can probably join our team of space volcanologists. As an assistant first, of course, but later, we'll see if you can take a better position in an intergalactic team. For now, you can stay in our solar system. We presume Mars, Venus, Pluto, and Jupiter's moon Europa have active volcanoes, but there's still no proof of that. The spots we know about for sure are moons Io, Triton, and Enceladus. Moon Finder. We have a department that's looking for new moons, even outside our galaxy. There's also another one where you get to visit and explore moons in our solar system. It has more than 200 moons, so you certainly won't get bored. If we're talking about a planet where you can't even land, like gas giants Neptune, Uranus, Saturn, and Jupiter, you'll visit their moons directly. All major planets have moons, except for Mercury and Venus. You'll have to visit these planets first and try to find their moon. Moons are awesome. For example, Dactyl is a moon that doesn't orbit a planet, but an asteroid. Before this, we didn't even know asteroids could have their moons. Hyperion orbits Saturn. It has an irregular shape, and we believe it's probably a part of a much bigger, ancient moon that got destroyed from a collision in the early stage of our solar system. It has a low level of density, almost half that of water. And what about Callisto, the oldest one? It orbits Jupiter, and its craters are 4 billion years old. Callisto helped us understand so much about our solar system. Space Jeweler. If you want to leave our solar system, you can visit what we call Diamond Planet. It's 41 light-years away from Earth, located in the Cancer constellation. It's twice as big and dense as Earth, but almost 8 times more massive. Its parent star contains way more carbon than our Sun, And this planet probably contains carbon too. The pressure and the temperature are huge, but we have a unique technology to deal with that. It's covered with diamonds, so your job is to collect it and make some amazing space jewelry. You can visit more interesting planets as a space jeweler, like one where it rains rubies and sapphires. The storms there are pretty crazy, but you only get to collect gems scattered across the planet after it's over. If you're more into making something out of glass, there's literally a planet where it rains glass. It's located 63 light years away from us. It's a little bigger than Jupiter, and you'll be amazed by the planet's atmosphere. It has a stunning azure color because it's mostly made of silicate. The wind there is crazy. It hits 5,400 miles per hour. For comparison, the fastest one we've experienced on Earth was 254 miles per hour. Oh, and the last one, Explorer, on the mission called Planet 9. Beyond Neptune, you'll see many small worlds peacefully dancing in harmony, and the stubborn one that's still hiding, the Planet 9. We've been looking at it for a very long time. Our scientists think it exists because they noticed gravitational force affecting a small group of objects with clustered orbits. Planet 9 probably orbits our Sun in 7,400 years. It's 6 times as massive as Earth. It's either a gas giant or some sort of mini Neptune, or even a rocky super-Earth. It's well paid, but I must warn you, it's a mission of your lifetime. We don't know when you'll be able to go back. It's far away. Neptune is the starting point of our investigation. It's a gas world, so you can't land on it. So you'll have to go to one of its moons called Triton. It's made of nitrogen ice and rock. You'll be fine. Just watch out for geysers there. They erupt on the crust, and then the atmosphere blows them away, and we're still not sure how dangerous they are. And you'll have to wear a special suit because that's the coldest space object in our solar system we know about. So, are you accepting any of the offers?
There are many different conditions on other planets and moons that could affect how your pet would evolve there. Take gravity, for example. On a bigger or denser planet, gravity would be higher, meaning that life would evolve to be shorter, sturdier, and perhaps with multiple limbs for structural support. On a lighter planet with weaker gravity, life could hop, soar, and glide more easily, and would be more likely to evolve a lighter, taller build. Mars is the 4th planet from the Sun, a dusty, cold, desert world. Mars is also a dynamic planet with seasons, polar ice caps, canyons, extinct volcanoes, and evidence that it was even more active in the past. Gravity on Mars is lower than on Earth, and it's farther from the Sun, so we would see less sunlight. Mars also has no protective magnetic field due to its thin atmosphere, exposing everything to radiation. Sometimes, strong winds create dust storms that howl around the whole planet, and the dust continues to settle for months after. Your pet dog on Mars would probably have a taller, robust build to compensate for poor gravity, and would have bigger eyes to better perceive the far-off sun. To protect itself from radiation, your dog would have to switch its pigmentation from melanin to carotenoids, which give carrots, tomatoes, and oranges their color. So the dog would probably have orange skin. Since Mars has weak gravity, your cat would probably be lighter and would jump more to get around the place. It would also have longer legs. Jupiter is called a gas giant. The planet is covered in thick red, brown, yellow, and white clouds. The clouds make the planet look like it has stripes. Living on the surface of Jupiter might prove to be challenging, since there's no actual surface. The planet consists entirely of gas, but it doesn't mean it's just a giant cloud hanging in space. If you venture through its atmosphere to deeper parts, the gas becomes denser until it turns into liquid. So one layer of Jupiter is an ocean made of hydrogen instead of water. With high pressure, extreme temperatures, and a fluid environment, we'll have to draw some inspiration from deep water dwellers who deal with the same conditions but on a smaller scale. Your cats and dogs would be big isopods with shells to protect them from Jupiter's radiation. Like its fellow gaseous neighbor Jupiter, Saturn is a gargantuan cloud of hydrogen and helium with no solid land and powerful winds. Like Jupiter, it gets tighter within, but its core is much smaller. Its iconic rings are made of a myriad of ice particles, so nothing could live on them, unfortunately. Saturn's volume is greater than 760 Earths, and it's the second most massive planet in the solar system, about 95 times Earth's mass. Saturn's average density is less than water, so this behemoth of a planet could float in a bathtub if there were one of a suitable size. The only way to move within Saturn's thick fog is by flopping around like a jellyfish. Your dog would probably have an umbrella-shaped bell to propel itself up, and no skeleton, so that it wouldn't be crushed by the pressure. Your cat would have jellyfish tentacles to move around. Life is tough on Mercury. This tiny planet is closest to the sun, so the sunlight here is 7 times more powerful than on Earth. No sunscreen would be able to manage that. Mercury is about 2/5 the size of Earth, with a similar gravity to Mars, or about 38% of Earth's gravity. This means that you could jump 3 times as high on Mercury, and heavy objects would be easier to pick up. Mercury's temperature is extreme, swinging between a scorching 800 degrees Fahrenheit during the day and negative 290 degrees Fahrenheit at night. It's all accompanied by constant meteor showers and quakes. As a bonus, there is a very thin atmosphere and no air to breathe. Flesh and bone could never handle these severe conditions, so instead, your pets here would be made of something similar to refractory metal, like titanium. There'd be no need for a respiratory system, so their pretty metal faces would be without a nose, and their eyes would probably look like thick sunglasses to protect them from all this sun exposure. If there's anywhere harder to live than on Mercury, it's Venus. Venus is the second planet from the Sun, and is Earth's closest neighbor in the solar system. Venus is the brightest object in the sky after the Sun and the Moon, and sometimes looks like a bright star in the morning or evening sky. The temperature here is a whopping 880 degrees Fahrenheit, and the atmosphere is so thick, it creates a greenhouse effect. The surface is dry and full of surprises like volcanic eruptions, hurricane winds, and lightning. And, as a cherry on top, the pressure here feels like you're 1 mile underwater, giving you a never-ending headache. It would be hard to imagine your pet living on Venus. The only things that could possibly survive there are anaerobic bacteria. Venus eats away at everything, even metal, making quick work of any human spacecraft. And Venus's atmosphere contains phosphine, which is toxic for anything that breathes oxygen, but means life for microbes. Icy, dark, and plagued by strong winds, Uranus and Neptune are mostly made of cold liquids, methane, water, and ammonia. Methane makes Uranus blue, and it has faint rings, while Neptune is dark, cold, and very windy, as it's the last of the planets in our solar system. It's more than 30 times as far from the Sun as Earth is. Neither of them has a solid surface, and their atmospheres slowly merge into the water around the planet's core. To boot, gravity on Neptune is stronger than on Earth, and applies more pressure on everything. With such powerful gravity, your dog would be shorter, and your cat would be stockier, with muscular bodies and thicker skins against the cold. And considering the fluid environment, your pet's best bet is to become like a cosmic whale or manatee, floating around the blue planets. Pluto is not very big. It's only half as wide as the United States. Pluto is smaller than Earth's moon. This dwarf planet takes 248 Earth years to go around the Sun. If you lived on Pluto, you would have to wait 248 Earth years to celebrate your first birthday. 1 day on Pluto is about 6.5 days on Earth. The farthest planet-like object from the Sun is appropriately freezing cold and covered with ice, with weak gravity and a flimsy atmosphere. The Sun, from Pluto, is nothing more than a dot on the horizon, much like the Moon for Earth, so there's not much going on in terms of light. But scientists suggest that there may be a water ocean under Pluto's surface and some nicer weather. Let's take notes from Earth's creatures with built-in antifreeze, like some insects and fish. Low gravity makes the muscles and bones shrink, and the space between vertebrae expand, making your pets taller. Their posture would also change, since their spine, for the most part, would be out of a job. So they'd probably be tall, thin, and somewhat spider-like, with spindly limbs and a curved spine. on other planets beyond the solar system, the boundaries between plants and your pets could be blurred, and your pets might merge with plant life. Your pets might become tree-like with beating hearts attached to their bodies, or with feet to move to better positions as they compete for light and water. You could also have a rabbit that spends most of its time staying still, photosynthesizing, and only running away if threatened. Or a massive dinosaur-like horse that splays itself out on the ground to get nutrients directly from the soil and obtains extra energy with the help of plants on its back. Cooperation could lead to some fascinating pets, such as a sea of amoeba, acting as a single jelly-like mega-creature, thousands of voracious shrimp-like carnivores forming a single organism that devours anything in its way, or a web of intertwined trees that collect water in wide pitchers at the top of their canopies. Getting oxygen to muscles is a key for your pet's endurance. Here on Earth, octopuses use a copper-based molecule in their blood to shuttle oxygen, making them more sluggish than mammals and birds that use iron-based hemoglobin. Scientists have speculated about other types of oxygen transport that could make animals fitter. In atmospheres with more oxygen, we might see a pet monkey that can fly without ever having to stop for a rest. On cold planets and moons without much sunlight, such as the moons of Saturn and Jupiter, your pet dog might have to get by with chemical energy rather than take it from the sun. Also, in worlds without light, such as the depths of Enceladus's oceans, there might be little need to evolve eyes. Pets would probably sense their environments using other means, like gills and vibration sensors.
We all remember seeing the Apollo lunar rover on the moon built for space missions in the 70s. Besides transporting astronauts for certain explorations, they were used for taking pictures and collecting soil samples for scientists to study. The vehicle was designed by Boeing, the company famous for building airplanes, and cost around $38 million to build. The kind of loose change you'd find today on Elon Musk's couch. In the far future, technologies will be so advanced that a regular car for the moon will behave like a regular SUV we have today. It'll have a sleek look and might be produced by some famous car manufacturers available. Back then, the lunar rover used a T-shaped throttle to move the car left, right, backward, and forward. The futuristic one can be voice-controlled and require minimal human control. And we can't leave out the Earth roof. Hey, you really don't need a moon roof on the moon. Anyway, the moon's driving conditions are not that extreme compared to Mars or other planets. It's hard to believe that the first landing craft to enter Mars was Viking 1, launched on August 20, 1975. It arrived at Mars on June 19, 1976. But decades later, Curiosity, which had 6 legs and 6 wheels attached, took the stage as the cute robot explorer. It was designed for the rough terrain, so in the distant future, a human-operated vehicle can have a similar design for people who want to cruise by the Mars sunset. For any human-designed car to work on planets other than the Earth, they have to be electric or anything else that can produce an unlimited supply of energy. Gas-powered vehicles won't work in the vacuum of space, and certainly not on any planet other than our own. It can be powered by the strong sun and convert the energy to run the vehicle. The interior has to accommodate the extreme conditions on the planet, since the atmosphere is very thin and unbreathable. It has to be very warm, since Mars can reach sub-zero temperatures. The matter of gravity isn't that extreme, but frequent dust storms are the problem. The vehicle will also have wheels attached to legs to maneuver around properly, since the terrain is difficult to get around in. Now, my 2 cents here? Well, I think an all-leather interior with 6-way seats front and back will be nice. Adding a 12-speaker sound system with RU Sirius FM radio is a must. Did I mention the Earth roof? Yeah, I did. And don't forget the 60/40 fold-down rear seats, so you'll have plenty of room to haul your camping gear on your weekend escapes. Meanwhile, it's still possible to have a panoramic glass view of the interior in a project like a tour bus on Mars. There are plenty of locations to discover, like the tallest mountain in our solar system and the snowy Carbon Peaks. The Red Planet can also have an express train ride that can take you from one place to another. It'll be one of those luxurious cabins that will take you from one landmark to another since Mars becomes colonized and established. The train will also be electric-powered or powered by another power source. Mars is a place where it's possible to have all kinds of vehicles, since the conditions aren't that different from Earth's. Just don't go outside without a helmet. If we designed a vehicle for Mercury, then get ready for bright light from the sun, in which case we would need to add industrial visors and blackout strips around the glass so that the sun won't get to us. At least we won't have to worry about the heat, since Mercury isn't the hottest planet in our solar system. Well, the temperatures can reach a soaring 800 degrees on a warm sunny day and drop down to minus 300 degrees at night. The vehicle will have to have multiple layers and coatings to withstand the conditions, and it will most likely have spider legs to move, since rubber wheels will melt instantly. And to save itself from damage, it'll need to dig underground to hide from the sun and atmosphere, just like a crab or those spiders that create hatch floors. Driving a vehicle on Pluto will be very challenging, considering that it's the furthest planet from the sun. Now, Pluto is technically not a planet anymore, but it's still a large enough mass to explore. Temperatures there can reach below 400 degrees. A mere jacket won't cut it. The vehicle will need super insulation to keep the operator warm and fuzzy. Methane ice surrounds the land and covers the mountains. Gravity is also an issue since it's very weak, which will make you float in the air. Now, designing a vehicle for Pluto will be tricky. The key for it to move and not freeze will be how the legs move. It'll also have legs like the one on Mercury, but will have a lot of heat generated to keep warm. The weight is enough to keep this vehicle in place. However, that can't be said for Neptune, the windiest planet in our solar system. It's impossible to breathe in the atmosphere, and the atmospheric pressure will crush you. Designing a vehicle is challenging, considering the many external factors, and will have to be pressurized to counter the external atmosphere. It will also need a special coating to counter the harsh temperatures. And because Neptune is extremely windy, it would need some sort of anchor to keep it in place, something like a large drill that shoots from the belly of the car and digs underground. It will also have spider legs to move around, but they'll behave in a similar motion to how a camel walks. That way, it can maintain its center of gravity. Now, Venus is the hottest planet in our solar system, with temperatures reaching 1,000 degrees. The pressure will crush your vehicle like a can, so it needs proper internal pressure to balance it out. This car will require all the upgrades for countering the heat. It will need proper coating, no glass, and even a special color to reflect the heat. Nothing can actually stay on the ground for too long, so spider legs won't really work. It'll need to hover slightly above the ground and float around. Now, Saturn is the second largest planet in our solar system and has a very windy upper atmosphere and very strong gravity. The rings around it are made up of ice materials that can range from the size of a pebble to the size of a school bus. The pressure is so strong that you'd be crushed the second you reach its atmosphere. Designing a vehicle would be very challenging and weird. It'll need the best technology for withstanding the crushing pressures and harsh temperatures. The vehicle will have to be large and composed of many internal layers. Since the upper atmosphere is windy, the vehicle will have to remain on the ground for as long as possible. Scientists don't know much of what the surface looks like, so the vehicle will have to be prepared to move on solid surfaces, liquid, and anything else in between. Now, I think it's called slop. It'll need mechanical arms to maneuver through the possible rugged terrain and multiple legs like a centipede. Those arms can pick up things and move them out of the way if it faces some obstacles. The long body can also detach itself and break into smaller pods for a quick escape. From what, we don't yet know. No human can step foot outside even if they wear protective gear. Robots will have to be deployed to test how human bodies can withstand the conditions. Jupiter has harsher conditions than Saturn, with the red spot being the most dangerous area on the planet. It's an extremely large area that has hurricane-like storms that have been going on for years. The vehicle will resemble that of Saturn, but extra heavy-duty. Scientists also don't know what's happening on the surface except for the crushing atmospheric pressure. The vehicle won't be able to move on the surface if it were to pass through the red spot, so it'll have to dig underground and move underneath. For that, it'll require a huge drill and many self-automated drones and vehicles that can be deployed from the main vehicle to help with digging and surveying. Once underground, it'll have legs that will help it crawl and a giant drill nose to dig further. Many of the body parts can also break off into smaller pods to get through certain terrains, but can be easily reattached. The craziest place where we can launch a vehicle is the Sun. There's no way to imagine it except being self-automated. Any human on board won't make it halfway in the journey. The launch will have to be from Mercury in a protective facility sheltered from the harsh temperatures. The vehicle will have to be made out of the best resources to withstand the extreme heat and gases, and won't last more than a couple of minutes once nearby. It'll most likely resemble a satellite and float around to take some footage for us to study. It'll probably cost trillions of dollars, but the results will be worth it, won't they?
An exoplanet is any planet inside our solar system. Some of them are free-floating. Those are called rogue planets. They move around the galactic center. Others orbit their host star, or two. For the first time, astronomers discovered exoplanets in the 1990s. Since then, scientists have found thousands of them. And now, you can sneak a peek too. Spoiler alert, some exoplanets are pretty bizarre. Others resemble our home planet and could probably support life. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. This means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth. Another Earth-like planet, TOI 700d, is 100 light-years away from us in the constellation Dorado. It orbits a small and rather cool dwarf star that is about 40% of the mass and size of the Sun. Its surface temperature is half as high as that of our star. The outermost planet, which is the very TOI 700d, is almost the size of Earth. It also sits in the habitable zone of its parent star. No flares from TOI 700 reach the planet. This increases the chances of the exoplanet being habitable. This means it can potentially develop and maintain life. Scientists don't know for sure the exact conditions on the surface of the planet, but one of the computer simulations they've created shows a planet covered with an ocean. It has a very dense atmosphere dominated by carbon dioxide. Astronomers think a similar atmosphere surrounded Mars when it was a young planet. But another 3D model shows TOI 700d as an all-land, cloudless world. That's what our Earth would probably look like if it wasn't covered with oceans. Winds on TOI 700d move away from the night side of the planet and meet in the area that directly faces the star. There is an exoplanet that stands out among the rest because of its awesome magenta color. You can find this world in the Virgo constellation. The planet is called Gliese 504b. The distance between this planet and its parent star is 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists received proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptional strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. If you traveled 20,000 light-years away from Earth, you'd come close to a red dwarf in the Sagittarius constellation. Such stars are very cool and small. Quite far away from this cold star, there's a planet. The distance between this world and its host star is so great that the planet receives very little heat. It's one of the coldest planets ever detected. The average surface temperature on the planet is lower than -360 degrees Fahrenheit. That's why the entire planet is covered with a thick layer of ice. If you stepped onto its surface, you'd see nothing but glaciers, plains, and mountains of ice. And still, astronomers claim life might exist deep beneath the frozen surface. All because the core of the planet is likely to generate enough heat to melt some of its inner ice. In this case, there would be an enormous subsurface ocean, maybe even swarming with bizarre life forms on the planet. One of the oldest exoplanets we know about is PCR B162026b. It's about 12.7 billion years old. It's almost 3 times as old as Earth, which appeared 4.5 billion years ago. This also means that the Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white dwarf and a pulsar, making almost 100 revolutions per second. Sunrises on this planet must look awesome. I bet the next exoplanet isn't like any other you might have seen before. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those of Saturn. The bizarre world is 434 light-years away from Earth. It's the only planet we know about that has rings similar to Saturn's. If you moved J1407b to our solar system and replaced Saturn with it, its rings would look many times larger than a full moon. Astronomers have noticed a gap halfway through the planet's rings. The chances are high that an exomoon the size of Mars orbits the planet somewhere within this gap. If you lived on this moon, you'd have an awesome view every time you looked up into the sky. This exoplanet, called WASP-12b, munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. This is likely to be the main reason for the insane temperatures on the surface of the planet. They can rise up to 4,600 degrees Fahrenheit. It's almost half as hot as the surface of the Sun. WASP-12b travels so close to its host star that it needs just 1 day to complete one orbit. Its night side isn't as hot as the day side, a mere 2,200 degrees Fahrenheit. Because of this difference in temperature, water vapor and clouds gather above the surface of the planet. From time to time, swirls of material from the planet's superheated atmosphere spill onto its star. About 4,000 light-years away from Earth, there's an exoplanet that might be one enormous diamond. It's 5 times the size of our planet, but needs only 2 hours and 10 minutes to orbit its parent star. It's a pulsar rotating at a rate of 10,000 times a minute. The planet is denser than any other we've discovered so far. It consists mostly of carbon, which is so dense that astronomers think it might be crystalline. If it was true, it could mean that at least some part of the planet is diamond. On WASP 76b, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit smaller than Jupiter and located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between WASP 76b and its parent star is 10 times shorter than the distance between Mercury and the Sun. That's why the star and the huge planet are tidally locked. One side of WASP 76b always faces the star, and the other side is always pitch black. This bright blue exoplanet sits 62 years away from Earth. A bit larger than Jupiter, it looks calm and peaceful. Its blue color might remind you of our home planet. But this familiar appearance conceals the planet's horrifying nature. The beautiful hue comes from silicate atoms and particles that make up the atmosphere. But the wind speed on the planet can reach 5,400 miles per hour. That's 7 times the speed of sound. The temperature there can rise up to 1,600 degrees Fahrenheit. But this isn't the worst. In this bizarre world, it rains glass, sideways. So it's probably not the place where you'd like to spend your vacation.
You're trudging up a steep sand dune, 1 foot in front of the other. Out of breath, exhausted. You've lost too much water, and your body is beginning to shut down. You know you can't go on for much longer. Finally, you reach the top of the dune, and there before you is what you didn't want to see. It's so horrible that it takes seconds to sink in. Stretching to the horizon is a literal sea of endless sand dunes. You're stranded, alone, lost, far from salvation on the planet Arrakis. There's really nothing more breathtaking than the fantastical worlds created in science fiction, from planets of ice to lush luminescent jungles. While this particular planet may only exist in literary and cinematic outer space, Arrakis is not a place you want to take your family to for a picnic. For those of you who haven't seen the 2021 movie Dune, don't worry, I won't spoil it for you. You may not have seen the 1984 version either, or the miniseries from 2000, several computer games, or read the 6 novels by its original creator, Frank Herbert. And yet, you know that much of the action in Dune takes place on the desert planet of Arrakis. No cute robots there, only harsh temperatures, and somewhere beneath the dunes, giant sandworms. And when I say giant, I mean massive. They can be up to 1,400 feet long, a third longer than the Earth's largest creature, the blue whale. Scientists wanted to know if people could survive on a planet of endless sand dunes. But before I talk about what they did, let's discover a little more about the planet itself. Arrakis is already populated by a people known as the Fremen. They are native to the planet and have adapted to survive its severe desert landscapes. They created a full-body outfit called a still suit. It's designed to preserve the body's natural moisture, such as sweating. It filters the impurities and circulates them back into catch pockets as drinkable water. Probably doesn't taste amazing, but it'll keep you alive. A still suit in good condition can allow the wearer to survive in the searing desert for weeks. If you or I were to be dropped on Arrakis, or indeed any desert environment, what would happen? It really depends on the temperature. Obviously, the hotter it is, the harsher the impact on your body. The first stage of dehydration is thirst. This occurs after you've lost 2% in body weight. You'll already begin to feel unwell. Water makes up 60 to 70% of the human body. In a hot environment, the body can lose up to 0.4 to 0.8 gallons of water per hour. You'll start to sweat less, and your body temperature will rise. your blood will become thicker and harder to maintain oxygen levels. Your heart rate will increase. You'll start to overheat like an old car, making you more tired and less able to function. By the time you've lost 4% of your body weight, fainting will occur. By 7%, organ failure begins. You get the picture. Pity that you didn't have a still suit. Thankfully, the movies don't physically transport us to such a place, so we can sit comfortably eating our popcorn and downing a large drink. I always get thirsty watching movies set in a desert. A group of British climate scientists must be passionate Dune fans because they decided to explore this planet in their spare time for fun. They built an actual 3D digital climate model of Arrakis. First, they collected all the data on Arrakis they could find. They scoured the Dune fandom wiki, as well as the incredible Dune Encyclopedia, a book with thousands of cross-referenced entries that took 8 years to compile. What they learned is that the atmosphere of Arrakis is made up of nitrogen and oxygen, enough for human life to exist. A good start. The planet's surface is almost entirely dry deserts. Yet there are also mountain ranges that shelter the planet's limited indigenous life forms, such as the Fremen. The giant sandworms that inhabit the planet also contribute to the planet's unique ecosystem. Their internal workings are like that of a blast furnace. They produce intense heat and, in turn, supply oxygen to the almost plantless world. Just don't get in their way if they're out for a Sunday stroll. Located deep within the mountains of the planet are water reserves. There are also small amounts of water in the form of vapor in the atmosphere. This water is harvested via wind traps. The polar regions have a milder climate and are more hospitable to humans compared to the vast, desolate wastelands of sand dunes. Thanks to those regions, Arrakis's overall geography makes it a relatively habitable planet, in theory. To find out if the geography and environment of Arrakis was physically possible or merely a set of fictional ideas, the scientists had to turn to a climate model. Fortunately, such technology already exists. It's used to predict weather and other climate factors. The scientists told the climate model everything they knew about Arrakis, including the planet's orbit and what the atmosphere consisted of. It's similar to Earth, though with slightly less carbon dioxide. The biggest difference in atmosphere is that Arrakis has a much larger ozone concentration, 0.5% of its atmosphere, compared to just 600,000ths of our own. With all of this complex data, they needed a giant supercomputer to process it. Even then, it took an incredible 3 weeks to get the results, but it was worth the wait. What they discovered was that in the warmest months of Arrakis, the temperature reached around 113 degrees Fahrenheit in the tropics. In the coldest months, the weather didn't go below 59 degrees Fahrenheit, not too dissimilar to Earth. In spite of that, the most extreme temperatures would actually be in the mid-latitudes and also in the polar regions, while the summers would be as hot as 158 degrees Fahrenheit, which is aligned with the book. The winters would be just as extreme, going from negative 40 degrees Fahrenheit in the mid-latitudes to as low as negative 103 degrees Fahrenheit at the poles. That's even colder than Alaska. How is this possible? The model showed that the polar regions of Arrakis have a much higher atmospheric moisture and high cloud cover, which would increase the temperature, as water vapor is considered a greenhouse gas. The book also mentions that there are polar ice caps, certainly in the northern hemisphere. In spite of that, the model revealed that the summer temperatures would melt any polar ice. Further to that, there would be no snowfall to replace the ice caps in winter. So much for a snowy winter's vacation. Another disparity is that no rain falls on Arrakis. Again, the model says otherwise. It proved that there would be rain, although only in small amounts. The rain would occur in summer and fall. It would primarily be confined to mountains and plateaus. There would be cloud cover in the polar latitudes and tropics as well. The scientists then posed the question that everybody really wanted to know: can humans legitimately survive on Arrakis? Realistically, the tropics would be the most hospitable place for people to live. Even so, most people in the dune world live in the mid-latitudes, where the hottest temperatures occur. Not very smart. The average monthly temperatures would be 120 to 140 degrees Fahrenheit. This would be lethal for humans, even with still suits. While the body would be kept cooler in line with the outfit's design, the skin is still exposed to the sun and heat. Not only would you look like a lobster, you'd probably fry. Youch! Life outside of the tropics in winter would also be impossible without technology. The cities would suffer extreme conditions in both winter and summer, akin to intense locations on Earth, like Siberia, which has brutal winters. Not the best locations in which to build your cities. No one could find fault with Frank Herbert, though, who passed away in 1986. His first Dune novel was published in 1965, though he'd already begun thinking about it in the late 1950s. He had visited the Oregon dunes and became fascinated by the movement of the sand dunes. He realized that without some type of vegetation, or poverty grasses which the Department of Agriculture was trying to introduce, the sand could move incredible distances. And with such force, it could swallow whole highways, lakes, and even cities. All of this was years before a man called Syukuro Manabe published the world's first climate model in 1967. In 2021, Manabe shared the Nobel Prize in Physics, the same year he turned 90, for the modeling of Earth's climate and predicting global warming. What a legend! Taking all of this into account, Frank Herbert wasn't far off the mark when it came to his fascinating world of Arrakis. While not strictly scientifically accurate, Arrakis is a realistic planet and humans could indeed live there. Just make sure you apply a thick layer of sunscreen in the summer. Herbert's novel Dune has sold millions and is considered one of the most influential science fiction novels of all time. His son Brian, already an author, took up the Dune mantle in 1999. He, along with author Kevin J. Anderson, have written many more novels in the Dune universe. The fascinating legacy lives on. Next time you plan on visiting Arrakis, please don't go in the summer. And make sure to bring your still suit. Water's pretty expensive.
The Moon is the Earth's closest space neighbor and its only natural satellite. It likely formed when a huge Mars-sized object crashed into our planet billions of years ago. I wasn't around then. This catastrophe turned Earth into a scorching ball of molten rock. It also pushed some material into its orbit, creating the Moon. Now, this heavily cratered sphere moves around our planet. This causes high and low tides around the globe. A bit more than 1/4 the size of Earth, it's the 5th largest natural satellite in the solar system. The Moon has several phases. For example, new, full, or crescent moon, first and last quarter. But whatever the satellite looks like, you can always find it in the night sky, and sometimes even during the day. But imagine waking up at night and noticing that the Moon looks somewhat different than usual. It seems brighter and bigger. It's hardly noticeable, especially when you're half asleep. You go back to bed, unaware that instead of the Moon, you've just seen Mercury. Close up, this planet, the nearest to the Sun, is similar to our natural satellite. Its surface is littered with craters left by space rocks. Mercury is about 2/5 the size of our planet, but it's still a bit larger than the Moon. That's why the planet would have a greater influence on Earth. Nights would become brighter. High tides would become higher, and low tides, what do you think, lower? Yup. The lunar cycle, that's the time the Moon, or rather Mercury now, needs to go through all the phases, would become 14 hours shorter. But all in all, such a replacement wouldn't have any drastic consequences for our planet. But then, how about Venus? What if, instead of the familiar satellite, we swap in the third brightest natural object after the Sun and the Moon? It's often called Earth's sister planet because their mass and size are nearly the same. Venus would be as large in our sky as Earth once appeared to the Apollo astronauts when they looked at it from the Moon's surface. The morning star would be much brighter than the Moon. For one thing, the planet reflects 6 times more sunlight. Plus, it would occupy an area at least 16 times larger. That's why nights on Earth would be as bright as early twilight now. If you looked at Venus, you'd spot vague swirling patterns in the planet's yellowish-white cloud cover. Venus wouldn't become Earth's satellite. The 2 planets would likely orbit around their common center of mass, and this orbit would be quite eccentric, like me. But if Venus moved with the same speed as the Moon has now, the 2 planets would crash into each other in the nearest future. Uh-oh. Okay, let's pull another switcheroo. If Mars was up there in the sky instead of the Moon, you'd surely notice it. Even without a telescope, you'd be able to marvel at its unusual color and dark spots on its surface. And even if you didn't see the red planet, you'd still feel something unusual. Mars is half of Earth's size, but several times larger than the Moon. Replacing a smaller space body with a much bigger one would upset the delicate balance on our planet. If you were unlucky to be at the seaside when Mars took the Moon's place, you'd have to evacuate as soon as possible. Massive waves would rise in the oceans under Martian influence. They would crash against the shoreline like the largest tsunamis. Mars would be reflecting more sunlight than the Moon. Nights would be lighter. Terrestrial landscapes would have an eerie red tint. And you'd be able to admire the tallest mountain in the solar system, Olympus Mons, through a telescope. Mars isn't large enough to change the Earth's orbit dramatically, but with time, the two planets would probably begin to orbit each other, creating a binary planet system. And since Mars would literally be next door, voyages to this planet would become a reality. Okay, now think really big. If Jupiter replaced the Moon, Earth, as an independent planet, wouldn't exist anymore. It would instantly turn into another moon of the largest planet in the solar system. The only positive moment in this transformation? People would have an awesome sky view. Jupiter is dozens of times larger than the Moon. A gigantic, beautifully striped sphere would cover nearly all the horizon. If you had time to enjoy the show, you'd see yellow, brown, red, and white clouds floating in Jupiter's atmosphere. Sadly, the gas giant's gravitational pull would instantly cause severe earthquakes, volcanic eruptions, and tsunamis. Earth's mantle and crust would be drawn toward Jupiter, which would break the planet apart. It'd be stretched and compressed with such force that its surface would bulge back and forth by more than 300 feet. Unfortunately, Earth's speed is only 10% of the speed needed for us to stay in Jupiter's orbit. That's why our sluggish planet would crash into the gas giant in less than a day. Well, that sounds unpleasant, so let's not do that. Now, if Saturn were to replace the Moon, it would be a sight to behold. The planet is more than 35 times larger than our satellite. It means the giant golden globe would cover 18 degrees of the sky, and its rings would stretch even further, from horizon to horizon. Hey, if you like it, then you should have put a ring on it. Earth would be a bit further away from the gas giant than its own moon, Dione. And since Saturn is way more powerful than our planet, Earth would turn into its satellite, not the other way around. Unfortunately, Earth's rotational speed wouldn't be enough to keep up, and we'd most likely crash into the much larger planet within a day or two. But before burning up in Saturn's atmosphere, we'd have to pass through its magnificent rings. They're made up of pieces of comets, asteroids, and shattered moons. It wouldn't be an easy feat to get through this space debris. Plus, our planet would have to avoid Saturn's moons, all 53 of them. But what if the fall didn't happen, and Earth did turn into Saturn's 54th moon? Then the gas giant's gravitational pull would lead to massive tectonic shifts all over our globe. They would be tearing the planet's crust apart until there's nothing left. Not good either. Both Uranus and Neptune are ice giants. These planets are the same size, larger than Earth, but smaller than Saturn and Jupiter. They both have icy interiors, deep atmospheres, and similar color. Very beautiful bluish green. If either of these planets replaced the Moon, the consequences would be the same. So, let's flip a coin. Okay, it would be Neptune you'd see in the sky one day. Neptune is 14 times larger than the Moon. The planet would look like a bright blue hot air balloon in the sky, not only at night but during the day too. It would appear to be 15 times larger than the Sun. If everything else remained the same, a solar eclipse would seem to continue for ages. Once the Sun vanished behind Neptune's edge, our planet would be plunged into complete darkness for no less than an hour and a half. Neptune is 17 times the mass of Earth, and its gravitational pull is much stronger. That's why our planet would end up as a satellite. Yep, again. It would orbit Neptune slightly further than its own largest moon, Triton. By the way, there would be a great risk of Earth colliding with this space body. But let's assume we were lucky enough not to cross paths with Neptune satellites. Even so, there would be more than enough problems on our hands. Tides on our planet would become 1,000 times more powerful than those caused by the Moon. Neptune's gravitational force wouldn't pull Earth apart, but it would heat our planet up. the seismic activity would increase, setting off earthquakes and volcanic eruptions, and probably louse up the internet too. So check this out. Astronomers have discovered an exoplanet they're calling Super Saturn. It's got rings over an AU wide. An AU is the astronomical unit, the distance between the Sun to the Earth. That's an incredibly huge ring system, hence its name. Super Saturn is being called Mamajek's object after the astronomer who led the team to whom we owe the discovery. Professor Eric Mamajek of Rochester University in New York found Super Saturn while scouring through data downloaded from wide-angle transit observations. WASP is the acronym for Wide Angle Search for Exoplanets. It's an ingenious project developed in the year 2000 by astronomers at Queen's University in Belfast, Northern Ireland, and St Andrews University in Scotland. Using 4 telescopes, the CCD video cameras on the scopes record the slight dimming of starlight caused by objects passing in front of stars. This is called the transit method of exoplanet detection. So, for example, the planet Venus transits across our view of the Sun every couple hundred years. A black dot, the silhouette of Venus, is visible, crossing in front of the Sun as Venus passes between our line of sight and the Sun. This tiny eclipse causes the amount of sunlight coming to Earth to be reduced by a minuscule amount, also known as teeny tiny. The same is true for all the stars in the Milky Way that have planets going around them. Exoplanetary transits in front of stars must be in direct line of sight with Earth for the starlight to be dimmed. Such transits do not occur very often. That's why thousands of stars must be looked at simultaneously for as long of a duration as possible, between 4 and 8 hours a night. WASP was created to stare continuously at as wide of a range of stars as possible. Maybe one of them would show an exoplanet transit. That translates into a lot of data being produced, about 40 gigabytes per viewing session. Computer scientists at Leicester University in England developed a computer program to store the data and generate photometric graphs of the light intensity of each star. Open University, also in England, joined the WASP project, took this data, and made it available for research by astronomers worldwide. The graphs of the intensity of starlight show that changes in its brightness are called light curves. These graphs have 2 axes. One is in the timeline axis, the other one is the intensity of light. As the object, considered an exoplanet, though it could also be a brown dwarf star, crosses in front of the star, the timeline axis keeps track of how swiftly it is moving. It tells us how close the object is to the star, while the brightness axis keeps track of how much the starlight dims. This way, we can find out how large the object is. Now, obviously, big objects will dim the light more and be easier to detect. At present, Earth-based equipment is not sensitive enough to measure the dimming caused by planets as small as Earth. Neptune's size and larger ones are the limit for WASP. However, the James Webb Space Telescope, which is now in operation, has a much greater sensitivity and will be able to resolve the transits of Earth-sized exoplanets. Now, I know you want me to get to Super Saturn, but there's something else you should be familiar with before we get there. If the exoplanet has an atmosphere, or, in the case of Super Saturn, a ring system, the starlight from the star the planet is transiting will shine through the atmosphere or ring system, and that can be detected too. The light curve will show less dimming in the photometric data, because not all the starlight is being blocked. Some light is still getting through the atmosphere or rings. This is important because it gives astronomers a reading of the atmosphere. The James Webb Space Telescope is fitted with spectroscopes that can determine the gas content of the transiting exoplanet atmospheres: oxygen, methane, carbon, etc. The WASP project has been really catching on. There's a Super WASP project now consisting of WASP North and a WASP South. One looks at the sky above the northern hemisphere, the other looks at the sky above the southern hemisphere. There's also a Next Generation Transit Survey, NGTS, based on the WASP project. It's automated, so astronomers don't have to stay up all night sipping coffee, but they can if they want to. Located at the European Southern Observatory in the Atacama Desert in Chile, the NGTS scans millions of stars and has discovered over 100 exoplanets, down to a size as small as 3 times the size of Earth. NGTS has started a Planet Hunters Club on social media. Citizen scientists can search the online database of light curves and perhaps discover your very own exoplanet. What had been a strictly British effort started by 1 or 2 astronomers is now a worldwide phenomenon. With the ability to read the spectroscopic signatures of atmospheric gases during exoplanet transits, a new idea emerged: technosignatures. That is, specifically identifying gases in exoplanet atmospheres that are produced by civilizations. The James Webb Space Telescope can do this. Gases from pollution, such as chlorofluorocarbons (CFCs), can be seen spectroscopically if present. Tritium from fusion reactions, if they have them, can also be detected, along with heat patterns from cities on the planet's surfaces. Technosignatures is a recent concept that originated after the WASP project started. Who knows what it will turn up? Now let's get back to Super Saturn. The star that Super Saturn orbits is J1407, a small, dim, sun-like pre-main sequence star of the 13th magnitude. Huh? Well, the human eye can only see stars to about the 6th magnitude, and each magnitude is 2.5 times dimmer than the previous one. So it's not an exceptional star, just another telescopic star out there in the Scorpius-Centaur region of the night sky. J1407 is a young star that hasn't yet settled into its stable, long-duration phase. This is important because Super Saturn, officially J1407b, is showing signs of having a ring system in an early stage of development. Super Saturn's light curve was tucked away in the mountain of data from the Super WASP project. Professor Eric Mamajek and his associate Matthew Kenworthy of Leicester University studied the data thoroughly and produced a detailed report on it. Knowledge depends on good data. The horizontal axis of J1407b's light curve, the time axis, is what's causing all the hubbub. It took Super Saturn weeks to transit across in front of its parent star, 56 days to be exact. Planetary ring systems that we are familiar with in our solar system orbit right around the equators of the gas giant planets and are very thin, from only a few meters thick down to a few centimeters. In a telescope, Saturn's rings will seem to disappear when the planet is at 0 inclination toward Earth. Saturn must be inclined at an angle in relation to Earth to see Saturn's beautiful ring system. It's something everyone should make a point of seeing: Saturn in a telescope. If Super Saturn's rings blocked most of the light from J1407 for 56 days, it means that the planet had to be orbiting at a steep inclination to its star. If it were at 0 inclination, we wouldn't see the rings blocking any light. Therefore, the orbital time could be determined 10 years minimum to 200 years if the orbit is highly elliptical. The superplanet itself is calculated to be 24 times the mass of Jupiter, which means that if it is gaseous, it could be a brown dwarf star. Super Saturn appears to have a Mars-sized object orbiting around it, because there is a huge gap in the rings that was most probably cleared out by a large object. The Cassini division in the rings of Saturn is where the moon Mimas has cleared out a path through Saturn's rings. The light curve of Super Saturn has only been observed once. All the exoplanet detection systems are keeping an eye out for it to come back around J1407. No one knows when that will occur. Some astronomers have suggested that J1407b is a brown dwarf star system in itself, merely passing in front of, but not connected to, star J1407. An orbital reappearance of Super Saturn would disprove that conjecture. The center region of Super Saturn blocked out all the light from its primary star. This is what indicates that the ring system is new and in an early developmental phase. Over time, the very dense ring mass close to the planet is expected to thin as all this matter gets absorbed into the planet or ejected into space. This is what has happened with our solar system's gas giant planets. The Mamajek object is a shocker. Never before or since has a light curve been detected like Super Saturn's. Super Saturn has added a new chapter to our understanding of the formation of ring systems. So, here's to you, Super Saturn. Hope to see you again soon. TRES-2b, or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, well, I'm not going to say that again, is the only exoplanet in the orbit of its star. And at first glance, it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better duck. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you? My mother. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you asked. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water, but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave or crazy enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw that thumbworth. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Karat Exo 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. Hey, ready to test your knowledge? Of course you are. You'll get 1 point for each correct answer. So, without further ado, the sun is yellow. Do you think this is a myth? Ask someone to draw a picture of the sun, and chances are you'll get a yellow or orange circle in the sky. Surprise! The sun is not really yellow. If you see it somewhere outside the Earth's atmosphere, it'll look white. How come? According to NASA, the sun's temperature is the reason why it's white. The sun consists of all colors mixed together, so it appears to our eyes as white. Then why do you think we see it as yellow or orange from Earth? Colored wavelengths, which are yellow and orange, are longer, and they are the only ones that make it to our eyes. The other short wavelength colors sprawl in the atmosphere, and the sky looks blue to us during the day for the same reason. Meteorites are hot as fire when they land on Earth. What do you think, myth or fact? When people see a fireball around a meteorite, they think it's super hot. Well, this is a myth. Meteorites don't immediately land on Earth. Most of them have been in space for billions of years. Space has a cold environment, just a few degrees above absolute zero cold, you know. But don't meteorites fall into the Earth in flames? How come? The fireball is actually the air in front of the meteorite. It is compressed by the super high speed of the meteorite. The outside catches fire, but that layer is burned off on impact as a result of landing on Earth. As you would probably guess, when they land, the meteorites are lukewarm at most, but not as hot as lava. One side of the moon is permanently in the dark. Do you think this is a myth or a fact? This is a myth. Oh, come on. First the sun and now the moon. Am I living a lie? So, people look at the sky and see only the bright side of the moon. The reality is the Earth shines equally on all sides of the moon as it rotates and orbits the Earth. Half of the moon is in shadow, and half gets sunshine similar to Earth. That's not true. Similar to Earth, it doesn't have a permanent dark side. The logic is simple. The moon orbits Earth, but it also rotates on its own axis. When you think about it, we're always looking at the same side of the moon. Black holes take in everything that comes their way. What is it, myth or fact? Black holes don't have infinite mass and gravitational force, but still, no one really knows for sure what happens to the things pulled into them. Experts do know black holes do not have supergravity, though. Let's imagine this. If there was a black hole as big as the Sun, it wouldn't immediately eat the whole planet. Imagine black holes as vacuum cleaners. It does draw in a cloud of dust near its range, but other specks of dust remain where they are. So even if there was a black hole replacing the Sun, all the planets would continue to orbit similarly. They wouldn't go into the black hole. If a star or something else got into the range of the black hole, only then would its gravity affect the star. When you call someone, the signal bounces off a satellite. Is this a myth or a fact? Yep, it's a myth. Or rather, an urban legend or misconception, you name it. I mean, there are some satellite phones, but we, regular people, don't use those every day. Although your mobile phone works in a much different way. When you call someone, the nearest tower connects you to the other person online. This is why there are tower connections, huge networks of tower-to-tower connections, and hidden cables. The moon has no gravity. Any guesses? Myth or fact? This is an urban legend. Ask any astronaut you know. If you don't know any, just trust me. There is footage proving that the moon has gravity. When I say the moon has gravity, don't think it's similar to the gravity on Earth that makes the apple fall. The moon's gravity is only about 1/6 of Earth's. How does it feel to walk on the surface of the moon? The second man on the moon, Buzz Aldrin, mentioned it's like moving in slow motion and, quote, perhaps not too far from a trampoline, but without the springiness and instability, end quote. The sunset on Mars appears blue. Do you think this is a myth or a fact? This is a fact. Magnificent sunsets. The sky is filled with different shades of yellow. Now imagine this in blue. According to NASA, sunsets on Mars would look bluish, watching them with bare eyes. It's because of dust. Dust particles closer to the sun appear in blue tones. There is something called moonquakes. Does it sound like a myth or a fact? It's a fact. Quakes happen on the moon too, and they're called moonquakes. They have different features, not really similar to the quakes on Earth though. A planet can be hot enough to vaporize rocks. Any guesses? Is this a myth or a fact? This is a fact. The temperature in this universe is indeed very high. There's a planet, the temperature of which is enough to melt and even vaporize rocks. It's 2 times bigger than the Earth. This super-Earth is similar to our planet, but it is way too hot. Experts believe that it possibly has oceans of lava and clouds that rain molten rock. 1 million Earths can fit inside the sun. Do you think this is a myth or a fact? This is a fact. Although the sun is one of more than 100 billion stars in the Milky Way, which is at the heart of our solar system, it can fit 1 million Earths. Yeah, it looks small when we see it from here, but it's only because it's so far away from Earth. All comets have tails, myth or fact? It's true. Some comets simply don't show their tails. They look like someone threw a snowball into space. Space is completely silent. What do you say? Shh, I knew it was too easy. This is a fact. Space doesn't have an atmosphere, so there's no way to hear any sound there. Mercury is the hottest planet. Myth or fact? Mercury is the closest planet to the Sun, so this should be a fact, huh? No, not really. Venus is the hottest planet in our solar system and the second planet from the Sun. But the distance from the Sun isn't what defines the temperature. The heat depends on the atmosphere. So Venus's atmosphere consists mostly of carbon dioxide and some nitrogen. This combination makes the atmosphere very thick. When I say thick, I mean it. Throughout the year, the surface of Venus maintains a temperature of around 860 degrees Fahrenheit. Mercury's surface resembles the temperature of a desert, but is much higher in terms of temperature variations. Venus spins clockwise. What do you say? This is a fact. Venus spins in the opposite direction compared to many other planets. The Sun rises in the west, and its rotation is very slow. Venus needs 225 Earth days to complete its spinning around the Sun. The planet's distance from the Sun affects the duration of one rotation. It's too close to the Sun, and the Sun has a strong, noticeable pull on the planets. Footprints on the Moon can stay there for millions of years. Do you think this is a fact or a myth? Fact checked. The Moon has no atmosphere, so there's no wind blowing, and without the wind, there's no way to erase the footprints without any intervention. So, how many points did you get? Let me know in the comments. The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler? NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our Sun is a yellow dwarf. And sorry, Sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our Sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the Sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our Sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. KOI 5715.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps down the road, we'll find some cool creatures on many of them.
There are almost no similarities between Earth and Jupiter. Ours is a sweet, small planet with plants and cute pandas. Jupiter is a giant gas horror with furious hurricanes which never subside. And if you fall into this planet, you might literally fly through it. But what would happen if our Earth was the size of the father of the solar system? Oh, this is going to be fun. Jupiter is a planet so big that I bet you can't even imagine its scale. Its radius is about 11 times the radius of Earth, and it's about 316 times more massive. So, to turn Earth into another Jupiter, we'd need to increase its radius by 11 times. If the planet's density remained the same, then the mass of our new Earth would increase greatly. Actually, it'd be as much as 4 times larger than Jupiter's. Of course, these changes wouldn't go smoothly. The very first thing that we would immediately notice, nope, not the size, gravity. It would increase by about 11 times compared to old Earth's. Scientists say we can actually survive on a planet with greater gravity, but only if it's less than 5 times stronger than what we have now. Well, let's assume that we're daredevils, always ready to challenge nature. What would our life be like? Well, not very pleasant. After each step, you'd have to sit down on a bench and take a break, as if you've just run a marathon. Yes, it would be that hard to walk. Oh, and good luck with getting up later. In order to somehow move around this planet, we'd have to pump up very strong muscles. No more problems with junk food, because you'd have to become a heavy lifter just to get to the refrigerator. The force of gravity affects not only movement, but also the size of everything. Do you know that many astronauts gain some height due to weightlessness in space? So if you're worried about being short, here's a solution for you. On the other hand, strong gravity would make us all shorter. This would go not only for humans, but for everything on our planet. Trees would become very small. To grow upward, they would have to move water from their roots to branches, which would be unrealistic with such gravity. So they'd all turn into little bushes. Also, no more mountains. Even the largest ones would become very small. But at least, now, everyone would be able to conquer Everest. This would also apply to animals. Our pets would have to quickly evolve into pumped-up corgis just to be able to walk somehow. Oh, and say goodbye to birds, of course. If you think that's not enough suffering, let's add another thing. It would be very difficult for us to breathe. Atmospheric pressure would increase dramatically. That's because Earth would start to pull air toward itself with great force. You'd literally feel the weight of it on your shoulders. Remember what I said about taking a break after each step? Now, imagine that you'd also have to breathe through a pillow. Yeah. And that's not all. Atmospheric pressure plays an important role in the behavior of water molecules. It would be much more difficult for water to boil or turn into ice. Most icebergs would melt, and it's possible that we'd have no more clouds, too. All water vapor would come crashing down on us in giant torrents of rain. We'd be lucky if we didn't get flooded instantly. But, oddly enough, there would also be some advantages. For example, everything around us would become much more spacious. Assuming we didn't get flooded, there would even be a bunch of deserted areas on the planet. Maybe land prices would finally fall. But these unexplored areas would most likely remain unexplored, since we'd hardly be able to travel across seas and oceans. Not only because moving across the water would be incredibly difficult, but also because all water bodies on the planet would become 10 times larger. The very thought of getting lost in the ocean is frightening, but imagine if it was 10 times deeper and bigger? Uh-oh. So, no more sailing. And forget about flying by plane, or visiting space ever again. But it seems like it's still not all. If Earth was the size of Jupiter, we'd also have volcanoes raging everywhere. Due to the increase in its mass, Earth would become terribly unstable. All extinct volcanoes would become active again, and there would be lava and poisonous gases everywhere. In 1883, there was the most destructive eruption in the history of humankind, the eruption of the Krakatoa volcano. It occurred on one small island, but people all over the planet could feel the consequences. The eruption destroyed the island, triggered many tsunamis, and clouds of poisonous gases spread for miles. Now imagine this, but 10 times worse. That's what would happen on our Jupiter-sized Earth. It would probably be similar to the fall of the Chicxulub meteorite, the one that wiped dinosaurs off the face of the Earth. Then, poisonous gases spread all over the planet, causing one of the greatest massive extinctions in the history of Earth. Oh, and we would also lose the magnetic field, like the cherry on top of the cake. The magnetic field is very important for life on Earth. According to Rory Barnes from the University of Washington, it shields life on the planet from the nastiness of space, which means all sorts of radiation and solar winds. There's a molten iron core inside our planet that is responsible for producing the magnetic field. If the amount of pressure on this core increased due to gravity, it could solidify. And because of this, Earth's magnetic field would disappear. We would be exposed to the effects of cosmic radiation. Too scary to even imagine. Alright, so now we know that living on this new Earth would be a real nightmare. But what about outer space? You've probably heard that Jupiter, thanks to its strong gravity, protects us from asteroids. Well, this would become our job. Jupiter experiences about 24,000 collisions a year, and now it'd be our destiny. Do you remember me mentioning the Chicxulub meteorite? Similar tragedies happen to our planet once every 100 million years or so. But if it became the size of Jupiter, these guys would visit us every Friday. Also, we'd have to say bye-bye to the moon. Our natural satellite is too close to us. So if Earth grew in size, it would be a real catastrophe. We would literally watch the moon being torn apart in the sky. Of course, after that, all these fragments would crash into us. One of the theories claims that billions of years ago, the moon somehow separated from Earth, and its pieces gathered into a ball. Now, it would be like watching its creation rewind. And even if the moon survived, somehow remaining in Earth's orbit, the changes in the tides would still be dramatic. The consequences of these changes would be very unpredictable, but probably a bunch of tsunamis would be some of them. On the other hand, we'd probably gain a couple of new moons. Jupiter has as many as 79 of them. It would probably be a spectacular view, if only gas clouds from all those volcanic eruptions didn't block it. Also, the appearance of a second giant planet would have significant consequences for the whole solar system. Don't worry, other planets wouldn't crash into us. Many people underestimate just how far the planets are from one another. But still, the new Earth would shift the orbits of other planets a little and affect the rotation speed. And Earth itself would rotate around the Sun much more slowly because of its huge mass. For example, 1 year equals 12 Earth years on Jupiter. All this, of course, would greatly affect seasons and the climate in general. So, would there be life on Earth? Bold of you to even ask this question. But if one day we do manage to find a habitable super-Earth close to Jupiter in size, it would be very interesting to take a look at it.
What would happen if our planet turned into two separate ones, one consisting entirely of land and the other one of water? Could we survive on any of them, and how? Well, you're lucky, because I'm going to answer this question right now. So let's imagine that our Earth has turned into two separate planets sharing one orbit. Let's call these hypothetical planets rock and water. I know, very original. Anyway, let's start with the rock because this one is much easier to imagine. All we should do is ask, what would happen if all the oceans on the Earth suddenly dried up? Now, we know that water is life. It covers 70% of the surface of our planet. There's so much water that even if all the oceans and seas disappeared, some of it would still be left in underground rivers, streams, and so on. But unfortunately, it would not be enough for us to survive. All sea creatures disappear. After some time, all other animals, plants, and of course, people share their fate. Completely dried forests burst into flames sooner or later and burn until there is nothing left but ashes. But hey, it's not that bad. Well, it is bad, but life can still exist in some form. There are some bacteria that make cockroaches jealous. They're able to survive absolutely any conditions. For example, extremophiles have already evolved to live without water. These little guys can survive in an incredibly hot or acidic environment without water or even sunlight. Without them, the rock becomes an empty, lifeless planet. Although, who knows? Maybe someday extremophiles will be able to evolve into some wildly cool forms that can survive literally anywhere. But for now, the rock is just a floating rock, basically. Oh wait, did you imagine a hot desert or some sort of red-hot steppes? Surprise, surprise! This planet is actually extremely cold. You see, without water, there would be no atmosphere. The atmosphere consists of a concentration of various gases, including hydrogen and oxygen. Some H and O, you know where this is going, right? Yep, no water, no atmosphere. And since it is the atmosphere that accumulates all the heat we need, the planet would be very cold without it. The contrast between cold and less cold places also becomes very sharp. You see, water is basically a climate stabilizer. The oceans absorb almost all of the heat of our sun. They distribute it evenly over the Earth to make sure it doesn't get too cold or too hot. So without it, the rock gradually turns into a cold desert. The average temperature on this planet is around minus 100 degrees Fahrenheit. At both poles, the temperature is extremely low, about minus 300 degrees. And even in the warmest places, it doesn't exceed 20 degrees. These warm places are now the former oceans because their dried-up depths are located much closer to the hot core of the planet. Wait, I hope you don't imagine this planet as covered in snow either. We don't have any water at all, remember? It's just a very cold rock. At this point, we're just a bigger and browner version of the moon. The moon is basically a waterless piece of Earth, after all. But hey, what happens to volcanoes? They're basically our last hope to stay warm, aren't they? Unfortunately, volcanic activity is decreasing due to a lack of water. You see, volcanoes and their eruptions happen because of the collisions of two tectonic plates, the oceanic and continental ones. The weight of the water presses on the oceanic plates. They go under the continental plates and form volcanoes. So if there's no water weight, then there's no volcanoes and volcanic activity drops significantly. The rock now is just a planet full of many incredible high mountains. And every time the tectonic plates collide, they form more and more of these mountains and trenches, including some very big ones, like the famous Mariana Trench. I would say, be careful not to fall, but hey, there's no one to fall there. So? Also, there's no weather anymore. No water means no more snow, ice, or rain, or even clouds. The wind would probably be quite strong, though. Well, that's the fate of the planet rock. Not very bright, so let's just go see how the water planet is doing. Many, many billions of years ago, I wasn't around then, our Earth actually was a planet entirely covered with water. Then, about 1 billion years ago, the sea level dropped. The land appeared. This has changed the atmosphere of our planet forever, and that's how life was born here. But what happens if it returns to its original state? Well, to answer that question, we should first learn more about the ocean planets. So, what does one of these look like? Oh, sorry, I almost forgot. We have no idea. We haven't found any planets of this type because they're incredibly rare. I mean, there is one planet that is low-key and could be called an ocean planet. Yeah, I'm not even going to try and pronounce that. Still, even this one doesn't look the way you probably imagine. The water on it is in a very weird, unique state. Scientists have called this hot ice or superliquid water, and we've never seen anything like this before. In general, though, the actual ocean planets are very hard to find due to many physical reasons. These planets require very specific temperatures, pressures, and so on. But alright, just hypothetically, what would such a planet look like? Well, first of all, of course, it cannot be made entirely of water. I hope you didn't actually think that there could be just some gigantic water blob spinning around a star. It should still be a planet with a core and some kind of foundation. So let's just imagine that all the water on the former Earth has mixed into one giant salty ocean. Wow, that would be a dream come true for the sea creatures, but not for the rest of us. The only animals that could survive in this situation, except fish, are probably the birds that can swim and feed on fish. Now, I think even if the sea level rose significantly, at least a couple of islets could still stay above the water. Such islands would be the former peaks of huge mountains like Mount Everest. So if these birds build their nests there, they can even survive for some time. But what about you and me? Well, we still have a chance. If we had enough time to prepare for the huge flood, we could stay safe either in giant submarines or on giant ships. We can grow food on board and fish from the ocean. But without the Everest Islands, we are unlikely to last long. If something breaks and we have nowhere to dock, we won't be able to fix it. Unfortunately, we no longer have drinking water. Now we can get it only from rain or by filtering seawater. But we have to store it someplace, right? And all these water containers would take up a lot of space and be very heavy. But in general, planet water is not as bad as it might seem. It's quite warm. The average temperature here is about 50 degrees Fahrenheit. And the gap between the lowest and highest temperatures is minimal, from minus 20 degrees at the poles to 70 degrees at the equator. Compared to planet rock, this ain't bad at all. Planet water would also be slightly larger than the Earth in radius due to the volume of, yes, water. The density of this planet would be, on the contrary, quite low. The gravity could become a bit weaker, too. Now, as for both planets, if we place them in the Earth's orbit, after some time, they would still move away from each other and follow different trajectories. They would have aligned themselves not to collide with each other. On one of them, the year would last 12 months, and on the other one, 10 or 11. And that's about it. A fun fact. All of this can actually happen in the future. First of all, the Earth's crust is gradually becoming thinner. Hey, I like thin crust. On my pizza. On my planet, not so much. So, one day, water can really flood our entire land. On the other hand, in a couple of billion years, when our sun begins to expand and turn into a red giant, all the oceans on our planet will really dry up. Alright, take a deep breath and shake it out. That's enough of this grim fairy tale. It's a waste of time to worry about such things so far off when, today, I can't find my wallet anywhere. I thought I put it over here.